Hello everyone, this video is about gradient function and differentiation notations. So if we have a straight line, the gradient at any point on the line is exactly the same. In this case, the gradient is simply 2 mx plus c. But if we have a curve instead of a straight line, well then the gradient changes. It depends at which point on the curve are we looking for the gradient here. So how do we find the gradient for the curve? Well, gradient as limit. So the secant line is the line that cuts the curve at two different points. This is called a secant line, the green line. So we have two intersections. Tangent is when we have only one intersection. So to find the tangent gradient, we can just use the concept of the secant, but we use 2 points which are close to each other. So the secant between when the x is k and the x is k plus d, but the d should be really small. So for example, we have this function y equals x squared. We are looking for the gradient when the x is 1. So we're looking for the gradient of the tangent line where the x is 1. So we're looking for around here is the tangent. So we can just use some points. For example, here if we use 1.1, and 3.9, then the gradient of this secant line will be y2 minus y1 over x2 minus x1, so we get 4. But this is not the tangent gradient when x equals 1, of course. So if you want to find the tangent gradient when x equals 1, we have to use the point which is really close to this 1, 1. So for example, if we use 1, 0, 1, when the x is 1, 0, 1, the y is of course 1.01, I mean 1.01 squared, which is 1.0201. So the gradient of the secant line is approximately equal to the gradient of the tangent. And if we use the gradient formula, y2 minus y1, x2 minus y1, we get 2.01. This is close to the tangent when the x is 1, or the tangent gradient when the point is 1, 1. So another example to approximate tangent gradient. For example, here the function is y equals x squared. We're finding the gradient when the x is 1. So we can use when the x is 1, 1.01, 1.1, 1.001. So here if we use these 2 points, when the x is 1 and 1.1, we get y2 minus y1, x2 minus x1, 2.1. If we use even closer or smaller difference, 0.01, we have 2.01, 2.001, so it is getting closer and closer to 2. And for another example, if the function is x cubed, we're looking for the tangent gradient when the x is 2. We can use something small, something close to 2. For example, 2.1, 2.01, 2.001. And as you can see, the m, or the gradient, or the tangent gradient, approaches 12. So that's how you find the gradient by approximating. Now actually we can use something called the gradient function. So for x squared, the gradient function is 2x. So when the x is 1, the gradient is simply 2 times 1, which is 2. So this is the exact value of the gradient. And for the x cubed, the tangent gradient, or the gradient function, is 3x squared. So when the x is 2, we can just plug in 2, we get 12. So 12 is actually the exact value of the tangent gradient of this curve when the x is 2. Now the process to find the tangent gradient function, or just the gradient function, is called differentiation. If you want to find the gradient function from the original, So the original function is usually we call it y or f of x. For the gradient function, we call it y prime or f prime of x or dy dx. So if the original is y equals x squared, the derivative, we call this the derivative, the result of the differentiation, the y prime equals 2x. This is called the derivative. So if the original or the y or the f of x is 3x squared, after we differentiate, we get 6x, which is the derivative. So that's it. I'll see you again next time.